All right, so that's section 5.3 is talking about a binomial random variable. So when you think of binomial, right, hopefully you think of this prefix bi meaning two. So that's going to be part of this section on binomial random variables. Very much related to a discrete random variable. There will be two sections covering binomial random variables. Okay, so what is a binomial setting? It arises when we perform independent trials of some chance process, independent trials, and we count the number of times that a particular outcome occurs, which is the success. What we're looking for is success rate, right? How many times does something occur? So there are four conditions for a binomial setting, and we abbreviate them BINS, bins. So again, just think of binomial setting, bins, right? So the first one is B for binary. Binary is like binary code for computers. Two, right? Binary two. So in this case, there's two possible outcomes, either a success or a failure. What you want to happen or what you don't want to happen. Only two choices, bi, right? Next, independent. The results of one trial cannot affect the other. They must be independent. And we'll talk about that a little bit later when we look at the formula. Next is the number. The number of trials, n, must be fixed. You must know what your n value is at the get-go. And then S stands for same probability. Again, it's more about the probability, but again, the probability of the success, P, must always be the same. That kind of ties into independence, right? So if the events were not independent, then that probability might change. Or depending on the groups, there might be a different probability within the group, something like that. So be aware of that. The probability has to be the same. So please, please, please try to remember this 4 acronym BINS for binomial settings. All right, so example 1 is blood type like a card game. Determine whether or not the given scenario describes a binomial setting. Justify your answer. We're going to justify our answer going through the BINS characteristics. If one of those fails, then it is not. A binomial setting. Again, I don't know why that made the B so big. BINS, right? They all should be big. All right, A, genetics says that the genes children receive from their parents are independent from one child to another. Each child of a particular set of parents has probability of 0.25 of having type O blood. Suppose these parents have 5 children. Count the number of children with type O blood. Okay, so the first thing is binary. B for binary. Are there only 2 choices? Well, yes. A success in this case would be having a child with type O blood. So I think I'm actually going to put type O blood first. Sorry about that. So B for binary, and actually we're going to write out the word binary too, right? Just extra emphasis, right? B for binary. So the success would be having type O blood because that's what we're counting. Count the number of children with type O blood. Type O blood is our success. So then to fail would be not having type O blood. So there's only really 2 choices, or not type O blood. Now you might say, Mr. Chappell, there's more than just type O blood. There's type A B, I think A negative, I don't know. But again, can you make the situation so there's only 2 choices? And you typically always can, right? It's either what you want or not what you want. Okay, so again, that word not's important. Next, I for independent. Independent. And up here, it says, genes children receive from their parents are independent from one child to another. So again, you're just going to write down some phrase that makes this. So we're going to say genes are independent from one child to another. From one child, I guess I should make that better. From one child to another. Okay, so they are independent. Great. Next is N for number. So how many kids are we looking at right here? Suppose these children have 5. The parents have 5 children. So your N value is 5 for the number of children we look at. And then S stands for same probability. And it says, Each child of a particular set of parents has a probability of 0.25 of having the type O blood. So that probability value P is 0.25. And as you can see, all four conditions are met. So yes, this is a binomial setting. And we could analyze it in that way. All right. Okay, let's look at the second example dealing with binomial settings. Okay, so it says shuffle a standard deck of 52 playing cards, turn over the first 10 cards one at a time, record the number of aces you observe. All right, so again, we're going to justify this using the Benz characteristics. So again, first B for binary. So we are looking for the number of aces. So an ace would be a success or not an ace would be a failure. So there are only two choices. Okay. And again, I know there's jacks, queen, kings, tens, nine. I know. But again, it's ace or not an ace. Next is independent. Okay. So it says we're going to turn over the first 10 cards one at a time. So say we take the first card, right? What is the probability of getting an ace on the first card? Well, the probability of getting an ace on the first card would be 4 out of 52 because there's 4 aces out of 52 cards. Now, because this problem does not mention replacement, it doesn't say we're going to replace the first card. It just says now we're going to look at the next card one at a time. Well, now say we did not get an ace and we didn't get an ace. Now the probability is 4 out of 51. These two events are not independent. The first turn affects the probability in the second turn. They are not independent. So we're going to say because cards are, and again, it's the idea that they're not replaced, not replaced. If each card was replaced, we shuffled and dealt again, this could be binary. But again, because the cards are not replaced, these events are not independent. And because it fails this condition, this is then not a binomial setting, not binomial setting. Okay. So again, hopefully that makes a little sense to you. And we can, again, remember this Benz idea for binomial settings. All right, that was objective 1. Objective 2 is coming.